Okay, so far we've been testing this convergence and divergence of series using several tests. And of course, we have two new tests in our arsenal that are going to help us determine that, and it is the direct comparison test for series and the limit comparison test for series. But already we have a bunch of other tests in our arsenal, which you guys should, be aware of, and you know what they are. If you hit pause and list them now, that would be great. But they are the geometric series test, the nth term test for divergence, the integral test, and the p-series test. And we even have a telescoping thing going on too. But the cool thing is we're going to get into the two new ones, which behave like what we did for improper integrals. And you guys already knew about this because you're like the smartest kids in the building. And you're saying, well, can't we use, compare series like a direct comparison test or a limit comparison test? And the answer is yes, you can. So let's start off with the direct comparison test. And suppose that a sub n is less than or equal to b sub n, which are both greater than 0 for all n. That's what that upside down a is. So we know if the infinite series b sub n converges, well, then so does the infinite series a sub n, because if he's above him and he's converging, then he's also going to converge because he's below. And synonymously, if a sub n diverges, well, then so does b sub n, because if he is smaller and is diverging and he's above him, then he's got to diverge too. So let's take a look at example 1. And if you're looking at example 1, I think in your mind you're telling yourself, I think I know what I want to compare him to. And if you do know, then hit pause and I'll see you in a minute, okay? But anyway, I'm thinking with you along those lines that I want to compare it to 1 over n squared. I know that 1 over n squared converges by the p-series test, because I know when p is greater than 1, I know that this series converges. Now, if I'm looking at these two, I know that 1 over 3n squared plus 2 is actually smaller than 1 over n squared, because if you take the denominator, you know that 3n squared plus 2 is always going to be greater than or equal to n squared on the interval from 1 to infinity. So we already know then, so that's basically saying that I know that the denominator down here is bigger than the denominator over here, so therefore their ratios are going to be quote-unquote smaller. So that tells me that 1 over this is actually smaller than this, and therefore this guy is underneath, and if this series converges, well, then this series converges. So we're going to say that that series converges right here, converges by the p-series test. Okay? Now, let's take a look at example 2. Example 2 is a little bit different. And example 2 is a little bit different because if I said to you, what would you actually want to compare this to? And I hope in your brains you're telling yourselves, I want to compare this to the geometric series 3 over 4 to the nth power, right? Because I'm seeing a geometric series, and I know that this series converges by the geometric series because 3/4, is less than 1. So I know that this guy converges. Now, like I did up here, if you look at the denominator, right, this would be, 3 to the n over 4 to the n. I know that 4n plus 5 is always going to be greater than 4 to the n. So we go over here and we say 4 to the n plus 5 is always going to be greater than or equal to 4 to the n from the interval from 1 to infinity. So therefore, since this denominator is bigger than this denominator, then the ratio makes this guy smaller than this guy, so he's underneath him. So therefore, I say that this series converges by geometric series. Okay, so as you're looking along here, what's kind of cool is we are employing other tests that we've used in the past when we're doing direct comparison tests and when we get into LCT. It's going to be also by the tests that we already know. Now, let's take a look at example 3. Okay, let's take a look at that one. And ask yourself, is that thing going to converge or is that thing going to diverge? I'm going to leave this example for you guys to work on, okay? I'm going to hit pause and we're going to move on, but I want you guys to actually evaluate or determine if example 3 converges or diverges and by what test you used, okay? So we'll go over that tomorrow in class, but we're going to move on to the next thing. I'll be right back. Okay, so over here, we are moving on to the next one, which is LCT, which you knuckleheads are all aware of. Suppose that a sub n is greater than 0, b sub n is greater than 0, and the ratio of their limits is equal to L, where L is between 0 and infinity. Then either both converge or both diverge. And remember, this is because we can't tell if something is above or below, blah, 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 blah. So the limit comparison test comes in, and that L'Hopital, and L'Hospital, as our friend Jason likes to say, comes into play. So let's take a look at example 1. We're looking over here at this guy over here, and if you're with me, I'm thinking to myself, I want to compare this to 1 over the p series 1 over n to the 1/2 or the square root of n. So I want to, whoops, change back to this guy over here. Get over here. I'm going to go with my pink because I just enjoy pink so much. Okay, so we're going to compare him to this guy right over here of 1 over the square root of n. And I know he diverges by p series, right? Because p is less than 1 because it's n to the 1/2, okay? So we're going to do LCT. So we're going to say by using LCT, right? We're going to do the limit as n approaches infinity of 1 over the square root of n over 1 over 2 plus the square root of n, which brings us to the limit as n approaches infinity of 2 plus the square root of n over the square root of n, which gives us, if we do our derivative, right, because we can do that this is infinity over infinity if I do L'Hopital, because now it's in that form, then I get 1 over 2 root n over 1 over 2 root n, which is equal to 1, which is our L, and L is between 1 and 0. So therefore, limit comparison test says, well, if this series diverges, well, then that series diverges. So we're going to say that the series diverges by the p series, diverges by LCT using the p series. That's the beautiful way of saying it. It says that this guy diverges by p series test using LCT. Okay? Okay. So I'm going to leave it up to you guys to do example 2, okay? Because example 2, if you look at that, right? You guys see what I'm saying? If you have the square root of n over n squared plus 1, what do you think you'd want to compare that to? I think that's the question you want to find out. What would you actually want to compare that to? And if I were you, I would hit pause at this time, and I would go ahead and decide what I wanted to do. And then when you turn this thing back on, you can see if you and I have the same thought process, if you will, okay? And you can see I'm just trying to erase this because that's what I do, okay? So here I have example 2, and like we said, we would want to compare it to, I sincerely hope you said, like I'm saying, I would want to compare it to 1 over n to the 3/2 power, okay? 1 over n to the 3/2 power, and you guys should recognize that 1 over n to the 3/2 power actually converges by the p-series test, because p is greater than 1, okay? So now we're going to go ahead and use that LCT that we wanted to use, and we're going to, I have room down here, so we'll just do this in green so we can actually see the difference. So we have the limit as n approaches infinity of the square root of n over n squared plus 1 over n to the 3/2, okay? And when you're doing all your mathematicas and all that jazz, then if I multiply this and this, right, when we start doing our little then I believe you get n to the 1/2, right, over n squared plus 1 times 1 over n to the 3/2. Yes? Is everybody with me on that? And we wind up with, I think, what am I doing here? Hold on, I'll be right back. I just realized what I did. This should be, hold on, this should be 1 over, go back over here, I'm so sloppy. I have this over 1 over this because we're comparing the two series. So technically this becomes n to the 3/2 over here, not over here. So we wind up with n squared over n squared plus 1, And that limit as n approaches infinity is in fact equal to 1. Because we would get 2 to the n over 2n over 2n, and that would just be 2 over 2, which is 1 if we kept doing L'Hopital for that. So we do wind up that this is actually in between 0 and 1, and this is L. So therefore, we can say, again, it converges by the p-series test using LCT. Now, the interesting one up and coming is this beauty right here, okay? Now, I want you to look at that, and before you even go on, I want you to tell me if you can even determine if that thing is going to converge or diverge, okay? And because what I want to do is move it up. I'm going to hit erase on some stuff here so I have some space to work. So as you can see, I'm moving this up here. And I'm going to hit pause and I'm going to erase some space. But in the meantime, I want you guys to really think about whether or not you think this is converging or diverging and why. And who you're going to compare it to. Okay. So I hope you guys said that this thing diverged. By I hope you guys said that this thing diverged by because 2 to the n is going to kick the crap out of n cubed. All right. So if you want to compare this guy right over here, technically I would want to compare him to the series n equals 1 to infinity of 2 to the n over n squared, okay? Now, because if you look at that, then that's pretty much as close as you're going to get to, the magic wand over here, okay? So my thing is this: you're looking at this guy right over here, right? And we know that this diverges. Why does it diverge? Which test tells us that this diverges? Please tell me that the nth term test for divergence is what it is, because if you do the limit as n approaches infinity of 2 to the n over n squared, yes, this will never equal 0. This actually goes off to infinity. So we know that this guy diverges, by the nth term test for divergence, okay? So we know that this guy diverges by the nth term test for divergence. And now that we have that in our arsenal, then we can go back over here and we're going to use LCT to actually show that it's doing that. So we're going to do the limit as n approaches infinity of n times 2 to the n over 4 to the n cubed plus 1. And if we do it over the ratio of, we're going to do 2 to the n over n squared. This simply becomes n, limit as n approaches infinity. Deal with me here, I'm just going really fast. So it's going to be n to the 2n over 4n cubed plus 1 times the reciprocal of this, which is just simply n squared over 2 to the n, okay? So we know that this guy cancels out with this guy, and we simply wind up with an n cubed over 4n cubed plus 1, yes? And by the time it's all said and done and we do our test here, we can basically see that this sucker is actually equal to a fourth, which is equal to our L, and it's between 0 and 1. So now we have shown that this guy right over here diverges by LCT. So this diverges by LCT using the nth term test. So we have several examples in our arsenal here that have helped us find out what it is that we need to find for these particular problems. And it's pretty exciting. Now, I'm going to come back, I think because I'm running out of time, actually. But I think what I want to do is I'm going to give this a shot. I'll be right back. Okay, so I have essentially no time, 1 minute left. This is 1 over n factorial. What I want you guys to do is if you expand 1 over n factorial, you get 1 plus a half plus a sixth plus a 24th plus a 25th, 1/25th, plus 1 over 750, because that's 1 over 6 factorial, dot, 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 right? Now, what are you telling me? What are you thinking here? You should be thinking to yourself, I wonder who I can compare him to, right? Who can I compare him to see if he's going to converge or diverge by either DCT or LCT? I'm going to leave you with that thought that 1 over n factorial can be compared to one of the series tests that we already have in our arsenal. So I'm going to talk about that tomorrow. So I want you guys to go and figure out what this 1 over n factorial is. And I wish you all the best. And I will have problems up there for you.